Mustafa and welcome back to my channel. Today we'll explore and show to you different ways and techniques to transform data into normal data, especially normal distribution data, especially skewed or positive negative skew data or distribution. As you know, several or many statistical tests like ANOVA or t-test, student test, or also ANOVA, Welsh ANOVA test, assume that our data or the data follows a Gaussian or a normal or a symmetrical distribution. In the case of a non-normal distribution, which is refers to skewed distribution, we cannot using this kind of parametric analysis or parametric test. So there is a twist. We can transform the data, the skewed data or the positive or negative skewed data into normal distribution data as shown in this figure. This figure illustrates the three types of distribution. First of all, we have symmetrical distribution or also normal or Gaussian distribution. In this case, the value of the values of mean, median, and mode are equal. There is a twist. The skewness coefficient in this case refers to or equal to 0. The skewness coefficient refers or equal to 0. The skewness is a measure of symmetric for distribution. When we have a normal distribution, the skewness coefficient is equal or very closely to 0. When we have a negative skew distribution, the skewness coefficient is equal to, for example, minus, for example, 1 or minus 0. For example, 5. So negative value. In this case, mode is greater than median and median is greater than mean. Inverse case in this kind of distribution, which refers to positive value of skewness coefficient, and also in this case the mean is higher than median and also the median is greater than mode. I will load two packages, moments using for I will use computing the skewness coefficient and ggplot to making our figures more elegant and beautiful to publish. And also I will select this kind of data frame, which is iris, using function hide to show the first 6 rows. And also I will select, for example, sepal length, and I will check if this dependent variable or response variable sepal length follows a normal distribution using this function Shapiro test, Shapiro underscore test from the package statics. So I will click to run. In this case, this results indicates that the p-value equal to 0.01, which is less than 0.05. So we can conclude that the sepal length, this dependent variable sepal length or response variable sepal length, doesn't follow a normal distribution and follow a skewed distribution. So we want to, for example, check if the sepal length follow a positive skew or negative skew using the following commands. So using skewness function and select iris and the appropriate variable. So skewness in this case coefficient refers to positive value, which is relates to positive skew. So for example, if we want to draw the distribution of sepal length, we can use it. We can use the command gg density iris sepal length. So this figure or this curve seems to looks like this kind of positive skew. So we want to transform this distribution of, or the value of simple length to a data that follows a normal distribution or symmetrical distribution. So there is 6 ways or techniques to transform the data. This ways depends of the level of skew. When we have a moderate skew, we use this square root for positive or negative, and when we have greater skew, we, for example, can use log 10 for even for positively skewed or negatively, and when we have a severe skew, we can use, for example, 1 divided by x. X in this case, for example, x here, and here, refers to the dependent variable, which is the response variable. So in this case, for example, we can replace x by, for example, iris and select the appropriate variable. So in this case, I will try to use this transformation function because I think that the value is, for example, refers to a moderate skew. So this output refers to the results after transformation, the results of simple length of the data frame iris after the transformation using square root. So square root is a function or is a technique using for transformation the data or the values of the data when we have moderate skew. So there is, for example, an information we should taken into consideration, and also in this case we should keep in mind that the new values or the new, for example, values after transformation, we should include in it in the data frame. So using this following, iris, for example, simple length dot at, which refers to after transformation, at equal, and we can copy this comment and paste it here. Use the following, for example, head. We should first of all go to the next step, which is check the normality of this distribution of simple length after transformation. We can check it using, for example, iris percent more than percent Shapiro test function from statics package, and select simple as uppercase dot, in this case, simple length dot after transformation, and click to run. So in this case also, this finding, our p-value indicates that the value of simple length after transformation is follow a non-normal distribution and follow a skewed distribution. In this case, we can, for example, apply another type or kind of techniques to transform the data, which is log 10, recommended for greater skew. So we should put or run, click to run, and this is new variable or new values of simple length after transformation using log 10. When also including in the iris data frame using this following iris. So this simple dot after transformation 2, which refers to results of the simple length after transformation using log 10, equal to and we should copy this comment and paste here and create the head iris. In this case, we have we will add 2 new variable in our data frame iris, which is simple length after transformation after application of square root, and simple dot length dot after transformation 2 after application the applying of log 10 function for greater skew. And we will check the normality of simple dot length dot after transformation 2 in our data from iris. Iris percent more than percent, apply Shapiro test function and select the simple dot. The S should be uppercase. 1, 2. So in this case, our p-value is more than 0.05, which indicates that the simple length after transformation 2 results after the applying of log 10 function is follow a normal distribution. And we want also to apply this transformation for severe skew. So we should replace this x by iris sublength. So this results indicates results of simple length after transformation using 1 divided by the values of simple length before the transformation. So we should also include in this third transformation into the data from iris. Iris, for example, after transformation 3 equal to, and copy this comment. Well, head iris. So this is the third variable that we have added here in our data frame, which refers to simple length after transformation. I will check also the normality of this variable using the following: iris and use the function Shapiro test simple. So in this case, unfortunately, the p-value is more also less than 0.05, so we should keep the second transformation, which represent or refers to simple dot length dot after transformation 2 using the log 10 function. So finally, we have successfully transformed the data of or the dependent variable simple length to data which follows a normal distribution. So we have transformed the positive skew data to symmetrical or distribution data. In this case, if you have any question or flag any concerns immediately, if you have any question or suggestions, please feel free to do so, and I will also include all of this comment into the comments below. Thanks for your patience. Bye bye.